Hi, Mr. Richards here. Today's algebra lesson is on using the distributive property. Before we actually factor this polynomial, let's figure out what factoring is. Well, factoring is to express a polynomial as the product of monomials and polynomials. Now, in order to use the distributive property to factor this polynomial, the first step is going to be to find the GCF, our greatest common factor. And we're going to find the GCF of 15x and 25x squared. Well, one way to find a greatest common factor is to use factor trees and prime factorization. So if we make a factor tree for 15, 15 is 3 times 5, and those are both prime numbers, so we've broken that down. And 25 is 5 times 5, and both those are prime factors, so that's broken down. Now 15x then is 3 times 5 times x, whereas 25x squared is 5 times 5 times x times x. And when we go to find the greatest common factor, what we need to do is look for the common factors. Well, we have the 5's, and we have an x in common. So our GCF is going to be 5 times x, or just 5x. Now, in order to factor this, let's start by rewriting the original, which was 15x plus 25x squared. And what we're going to do is try to divide out the GCF from each. So we're going to divide out the 5x from both 15x and 25x squared. Well, one question we can ask ourselves then is, 5x times what is 15x? Well, how about 3? 5x times 3 is 15x. And one unique thing, if you were to list out your factors in prime factorization, is that what's left here is 3, and what was left there was also 3. Another way to ask the same type of question is, well, 25x squared divided by what is 5x, or 25x squared divided by 5x is what? Well, that would be 5x. And again, notice how we have the 5x left. And now all we have to do is take out this 5x and rewrite those numbers in those parentheses as 3 plus 5x. So our answer is 5x times 3 plus 5x. Now, a way to check your work, even mentally, is to use the distributive property to see what you would have. 5x times 3 is 15x, and 5x times 5x is 25x squared, so we have the correct solution. Now, what about this question? Use the distributive property to factor this polynomial. Well, we have 12xy plus 24xy squared minus 30x squared y to the 4th. And if you can look and find the GCF, awesome. But for this question, let's continue to make factor trees to try to break these down, as 12 is 4 times 3 and 4 is 2 times 2. There's nothing wrong with needing to make factor trees to make sure that you have your GCF correct. 24 is 4 times 6, and 4 is 2 times 2, and 6 is 2 times 3. And then lastly, we have our 30, and 30 is 3 times 10, and 10 breaks into 2 times 5. And now, what we can do is once again list out these factors. 12xy is going to equal 2 times 2 times 3 times x times y. 24xy squared breaks into 2 times 2 times 2 times 3, and then our variables times x, and y squared is y times y. And then lastly, this negative 30x squared y to the fourth. We do something special because of that negative. Our first factor is actually going to just be negative 1, as that was a negative number. And then we can do our times 2 times 3 times 5. And then x squared was x times x. Y to the fourth is y times y times y times y. Now, what are our common factors? We have a 2 in each, so we have 2, 2, and 2. We have a 3 in each, so this 3, and the 3 here. And then we have an x in each. And we have a y in each. And so that our GCF, our greatest common factor, is going to equal the 2 times 3 times x times y, which is simply 6xy. And again, that is a lot of work to get down to your greatest common factor. But the key when you factor polynomials is you have to factor out the greatest common factor. If you don't factor out the greatest common factor, then you're not correct. Now, if we rewrite the original polynomial, we had 12xy plus 24xy squared minus 30x squared y to the fourth. And the number we're dividing out of each of these is our greatest common factor of 6xy. So 6xy times something plus 6xy times something else. And we'll keep this plus 6xy times our last thing. Now, to figure out what's going inside each of these parentheses, again, you can ask yourself a couple different questions. You could say 6xy times what is 12xy? Well, that answer is 2. And again, if you listed out your factors, you would see that that 2 is remaining. Or you could ask yourself for the next one, well, 24xy squared divided by 6xy leaves me with what? Well, 4. Why? And again, what's left up here is 2 times 2 and a y, so that's another way to get to 4y. And then 30x squared y to the fourth, or that's actually going to be a negative 30x squared y to the fourth, divided by 6xy leaves you with negative 5x y to the third. So now we rewrite this with our greatest common factor, 6xy on the outside, and then these numbers on the inside, 2 plus 4y, and then that's a negative 5, so minus 5xy to the third. So our answer is 6xy times 2 plus 4y minus 5xy to the third. And again, even mentally, if you were to check this using the distributive property, 6xy times 2 is 12xy. 6xy times 4y is 24xy squared. And 6xy times this negative 5xy to the third ends up being negative 30x squared y to the fourth. Now you can also factor by grouping, and there are a couple conditions that all of which need to be met. There have to be 4 or more terms. The terms have common factors that can be grouped together. And there are 2 common factors that are identical or additive inverses of each other. Now, the common factors that can be grouped together, as we look at these terms, 2xy, 7x, 2y, and 7, we can think to ourselves, well, this has a 2y, and this has a 2y. So I can group those together. This has a 7, and this has a 7, so I can group those together. And so as I do that, I would be left with here 2xy grouping with the minus 2y plus the 7x grouping with the minus 7. Now, what can we pull out? Well, we can pull out our greatest common factor. And the greatest common factor of 2xy minus 2y, in fact, is 2y. So I would have 2y times x minus 1, as the 2xy divided by 2y is the x, or you could ask yourself, 2y times what gets me 2xy? That was the x. And then 2y divided by 2y is the 1, so minus 1. Then, what can we pull out of the 7x minus 7? Well, just a 7 we can divide out. And what are we left on the inside with? Well, 7x divided by 7 is x, and negative 7 divided by 7 is minus 1. And notice, now we have x minus 1 and x minus 1. So I can regroup this now with the 2y plus 7 being pulled out here times the x minus 1. And that's a possible answer, 2y plus 7 times x minus 1. Now, if you could also rewrite this as x minus 1 times 2y plus 7. Both of these answers turn out to work. Now, a way to check this, since we have 2 polynomials being multiplied by each other, or actually 2 binomials being multiplied by each other, is to FOIL. We could do 2y times x, and that's the 2xy. The outer, 2y times negative 1, gets us that minus 2y. The inner, 7 times x, gets you the plus 7x. And the outer, or the last, excuse me, 7 times negative 1 is negative 7. So it works. What about this polynomial? 15a minus 3ab plus 4b minus 20. Well, when we go to regroup these, there's actually not much grouping to do because we have our 15a and 3ab, which looks like we can take at least an a out of. And then we have our 4b and our minus 20, which we can at least take a 4 out of. So as we regroup these, it's actually just kind of still there. 15a minus 3ab in one of the groups, plus 4b minus 20 in the other group. Now, what can I pull out of 15a minus 3ab? The greatest common factor here is actually 3a. I can divide a 3 and an a out of both. And that's going to be multiplied by 5 minus b. Now, what about the next one? Well, I can divide a 4 out of both of those. What I'm left with here is b minus 5. Now, 5 minus b and b minus 5 are not the same thing. And if we look up in our third condition, there are 2 common factors that are identical, which they are not. They were in the first example. Or additive inverses of each other. The additive inverses is our key here, meaning I can multiply a negative 1 in here, or divide out a negative 1. And so one method of solving this is to say, all right, right here, I am going to pull out a negative 1. So I'm going to multiply by negative 1. What does that leave me with? Well, 3a times negative 1. And if I multiply the 5 and the negative b by negative 1, what I end up with here, 5 times negative 1 is a negative 5. Negative b times negative 1 is b. So that's b minus 5. And then I still have my plus 4 times b minus 5. It's a unique way of being able to group these. Now, if I simplify this, 3a times negative 1 is negative 3a. And then I still have my times b minus 5 plus, nothing happens here, 4 times b minus 5. And so as I go to regroup this now, I'll have my negative 3a plus 4 in one group and b minus 5 in the other group. And that is a possible solution here. Negative 3a plus 4 times b minus 5. Now it is possible to go the other way with this. I mean, if I rewrite this out as 3a times 5 minus b plus 4 times b minus 5, what if I chose to multiply by a negative 1 here instead on the right polynomial? Well, I would still be left with here then 3a times 5 minus b plus the 4 times negative 1. And if I'm multiplying that by a negative 1, what happens to my b and negative 5? Well, b times negative 1 is a negative b. And negative 5 times negative 1 is a 5. So that's just 5 minus b now. And I have the same thing. So if I go to simplify, I have the 3a times 5 minus b still. But then this changes into a plus 4 times negative 1 is negative 4 times 5 minus b. And now I can pull out the red ones. So 3a minus 4 multiplied by the blue, 5 minus b. And actually, both answers are correct. So whether you write it as negative 3a plus 4 times b minus 5 or 3a minus 4 times 5 minus b, you would be correct. It's the same answer. Now, the second part of this lesson involves the zero product property. It states if the product of two factors is 0, then at least one of the factors must be 0. I mean, when you really think about it, for two numbers to multiply to be 0, one of them has to be 0. If I have 5, the only way to get to 0 is to multiply that 5 by 0. So how that applies here is we have two factors, really, x minus 2 and 4x minus 1. One of those two must be 0. So what I can do then is say, well, either this x minus 2 has to equal 0, or this 4x minus 1 has to equal 0. So we're actually going to have two answers here. So we need to solve for x in both. If we add 2 to both sides here, this cancels out, and we are left with x equals 2. That is a possible solution. Now to solve this equation, it just takes one more step. We start by adding 1 on both sides, so we have some cancellation going on there. 4x is going to equal 1. And don't freak out if you get a fraction answer, because x is going to equal 1/4 here. And so our answer, the way we're going to write this is the roots are 2 and 1/4. And that's our solution. Now, there is a check step. There is a way to check to make sure that we have the right answer. As with all of our check steps in equations, we start off by writing the original equation. So x minus 2 times 4x minus 1 needs to equal 0. And we're going to solve both of these answers, or check both of these answers, one at a time. You're not going to put in 2 for one of the x's and 1/4 for the other. You're just going to pick one. So we'll start by taking the 2 and put that in for x. So 2 minus 2 times 4 times 2 minus 1, and that needs to equal 0. And 2 minus 2, conveniently enough, is 0. And then you have this 8 minus 1 here, which is 7, and that needs to equal 0. And sure enough, 0 times 7 is 0, and that equals 0, so you're checked out for that one. Now, what about the 1/4? Well, if we have x minus 2, again, times 4x minus 1, and that equals 0, let's put in the 1/4 for x. We have 1/4 minus 2. That's going to be multiplied by 4 times 1/4 minus 1. 1/4 minus 2 is negative 1 3/4. And that's going to be multiplied by, well, 4 times 1/4 is 1 minus 1. So negative 1 3/4 times 0 needs to equal, well, 0. And sure enough, it does. So whether you put 2 in as a root or 1/4 in as a root, both work. So both 2 and 1/4 get 0 and are our roots. Now in our next zero product property question, we don't have a 0 yet. We say to solve the equation and check your solution, but we don't have a 0, so we need to work to get a 0. So if we subtract 4y now on both sides, a kind of neat thing happens. That cancels into nothing, but it's not nothing, it's really 0, equals 12y squared minus 4y. Now, remember back in the previous example when we had x minus 2 times 4x minus 1 equals 0? It was already factored for us. Well, guess what? Now we have to factor 12y squared minus 4y. And when you think about the GCF, what's the biggest thing I can divide out? The biggest thing we can divide out of here is 4y. So 0 is going to equal 4y times 3y minus 1. Yes, 12y squared divided by 4y is 3y, and negative 4y divided by 4y is negative 1. And now I can set both of these equal to 0. I could say 4y could equal 0, or 3y minus 1 equals 0. Now the first one's quite simple to simplify. You divide by 4 on both sides, and y equals, well, 0 divided by 4 is 0. Now the next one, we start off by adding 1 on both sides. Get some cancellation there. 3y equals 1. And divide by 3 now on both sides, and y equals 1/3. And so the way we're going to write this answer is the roots are 0 and 1/3. And when it comes time to check, it does say to check our solution, we'll have our 4y equals 12y squared. And if we start off by putting in the 0, 4 times 0 needs to equal 12 times 0 squared. Well, 4 times 0 is 0. And 0 squared is 0 times 12 is 0, so that quickly checks out. What about the other one? Well, 4y needs to equal 12y squared. And if we put in 1/3, let's see what happens. 4 times 1/3 needs to equal 12 times 1/3, and that 1/3 is squared. Well, the left side is going to simplify right now, as 4 times 1/3 is 4/3. Well, we get that on the right side. Well, we'll have the 12 is 12 over 1 times 1/3 squared is 1/9. Well, if I just cross simplify here, divide by 3, you get 4. Divide by 3, you get 3. You end up with 4/3 equals 4/3. So my answer works. So the roots of this equation are 0 and 1/3. And now as we conclude this lesson, it's time for our real-world word problem. Say that 10 times fast. A football is kicked into the air. The height of the football can be modeled by the equation h equals -16x squared plus 48x, where h is the height reached by the ball after x seconds. Find the values of x when h equals 0. So let's rewrite our equation. We have h equals -16x squared plus 48x. Well, we are using the zero product property, and we're also looking for the height or the values of x when h equals 0, so 0 is going to be our h, equals -16x squared plus 48x. Now we do need to find the greatest common factor of -16 and 48. And even if we go back to our factor trees, a neat thing kind of happens here that's a bit of a shortcut. 48 you can break down into 16 and 3. And if you look at that 16, it's like, hey, that works. I can use the 16 as part of my GCF, and indeed you can. You can take out, actually in this one, a 16, and both have an x, so 16x. That's going to be multiplied now by a negative x plus 3. And those are our two little mini equations we get to solve. 0 equals 16x, and 0 equals negative x plus 3. Well, the first one's quite easy again. We divide by 16 on both sides, and 0 divided by 16 is 0 equals x. And then the next one, typically we'd subtract 3 on both sides here, but I challenge you to do something different. This is a negative x. So if I add x to both sides, this cancels, and I'm left now with x equals 3. So to find the values of x when height equals 0, the height of this ball was 0 when we were at 0 seconds. That makes sense. It's before we kicked it. And then at 3 seconds. So our football had a 3-second hang time. That is it for this lesson on using the distributive property. Good luck.